We'll be solving equations with fractions and with decimals here. We're going to do our first equation in two different ways. The second way is going to be the way that we'll typically do it. The first way is going to be to talk through why that second way will work, and then these three examples. So, our first problem. If I am trying to solve this equation, well, I've got variables on both sides of the equation. So, I want to collect variables on one side of the equation. 3/4 x plus 2 is 1/6 x plus 1/4. I want to move this 1/6 to the other side. It's a positive 1/6, so I'm going to subtract 1/6 x from both sides. Now on the right side, 1/6 x minus 1/6 x is 0, and we're just left with our 1/4. On the left side though, I'm going to want to do some scratch work, because what I have here is 3/4 x minus 1/6 x, and then I'll still have my plus 2. Well, 3/4 minus 1/6, to add to or subtract two fractions, I need to have a common denominator. 4 and 6, the least common multiple is 12, so the 6 needs a 2. I can only multiply by 1, or I've changed my expression, so I have to multiply by 2 over 2, so I've multiplied that fraction by 1. The 4 needs a 3. 4 times 3 is 12, so I have to do the same thing to the numerator, so I have only multiplied by 1. 3 times 3, I've got 9/12 minus 2/12, so I have 7/12. Now, this was all this part, 3/4 x minus 1/6 x, and that gives me 7/12 x. Variables are on one side. I need to move my constants to the other, so I need to get rid of this plus 2. I'll get rid of a 2 that was added by subtracting 2 from both sides. Notice how I'm starting to put a few steps together rather than rewriting that a second time. So that's going to give me 7/12 x plus 2 minus 2 is 0 equals, off to the side for my scratch work, 1/4 minus 2. 2 is 2 over 1. I need a common denominator. So I have 1/4 minus 8/4, or negative 7/4. So 7/12 x is negative 7/4. To get x by itself, I need to get rid of that coefficient, 7/12. I can do that by dividing by it. Well, dividing by 7/12 is the same as multiplying by 12/7. The 12s will cancel, the 7s will cancel. What I did to one side, I have to do to the other side. Be careful here. If this is multiplication and you've got a sign, be sure you're using the parentheses. The 12s cancel, the 7s cancel, leaving behind 1s, so I have 1x. Here, 4 goes into 12 3 times, and 7 goes into 7 1 time. X is negative 3. If I do a check of that, I'll be saying 3/4 times negative 3 plus 2 is 1/6 times negative 3 plus 1/4. If you actually work out this check, you're going to get negative 1/4 equals negative 1/4. And again, keep practicing with those checks. The problem with this is we're going to be doing a lot of scratch work to the side, getting those common denominators, and if it's difficult to find the common denominator, this is going to be horrible. So the key here is to remember that with an equation, as long as we do the same thing to both sides of the equation, we're okay. So instead of that way, here's the exact same equation, but what I'm going to do now is say, hey, it's an equation. I can multiply both sides of an equation by any number I want as long as I don't multiply by 0. I'm going to multiply by and then pick a number that is a common denominator for all of your fractions. So we have 3/4 x plus 2 equals 1/6 x plus 1/4. my denominators 4 and 6. Well, you should be able to see pretty quickly that 12 is the least common denominator. If, however, you don't see the least common denominator quickly, I could multiply both sides by 4, simplify, and then multiply both sides by whatever was remaining in a denominator. So I'm going to multiply both sides of the equation by 12. Now, be careful. This is going to give me 3/4 x times 12 over 1 plus 12 times 2. That distributes to both terms. Typically, with some practice, you'll do this step mentally. 4 goes into 12 3 times. 3 times 3 is 9, so I have 9x. 12 times 2 plus 24, which is exactly what we'd get here. 4 into 12 3 times. Same thing here, 1/6 x, 12 over 1 times that, plus 1/4 times 12 over 1. Well, 6 goes into 12 twice. 2 times 1 is 2, so I have 2x. Matches up. 4 goes into 12 3 times. 3 times 1, 3. And I've now got an equation that if I were comfortable with algebra tiles, I could use algebra tiles to solve, whereas I can't do that from the beginning. So here, variables on one side, constants on the other. To get rid of this 2x, I'm going to subtract 2x. You notice I'm leaving a little bit of space at least and showing in another color what I'm doing on both sides. 9x minus 2x is 7x. 2x minus 2x is 0, leaving just the 3. Variables are on one side. Move the constants to the other. I want to get rid of this positive 24, so I will subtract 24. 7x, 3 minus 24, is negative 21. To get x by itself, the 7's stuck by multiplication. Undo multiplication by division. X is negative 3. Exactly the same answer we got as last time, but the arithmetic is significantly easier because I don't have to do this scratch work with my fractions. Here I've just got nice, easy integers to work with. So that's the key. And again, the reason we can do this is because with an equation we can multiply or divide both sides of an equation by any non-zero number as long as we do the same thing to both sides. So let's see how it works as it gets more complicated. Now, the thing here to be careful with is you've got to know how the distributive property works. So to avoid making careless errors, I will always strongly suggest that you clear parentheses before you try to clear fractions. So that's going to give me 7/15 x minus 1/5. 2/5 times x is 2/5 x. 2/5 times 1/2. I can do that as scratch work to the side if I want. One-fifth. So I have fractions, but I no longer have parentheses. 15, 5, 5, and 5, well, I'm going to multiply both sides by 15. Now, I am going to, in this case, rewrite that line and show the multiplication, because that way, if I've made any careless mistakes, I can go back and check it much easier. So multiplying both sides of the equation by 15, I've multiplied both sides of the equation by the same non-zero number. That's okay. 15 goes into 15 once, 1 times 7. I'm left with 7x. 5 goes into 15 3 times. 3 times 1 is 3, minus 3. 5 into 15 3 times. 3 times 2, 6. 5 into 15 3 times. 3 times 1, 3. And I've got an equation that is much nicer, a lot easier to solve. So I want variables on one side, constants on the other. To move the 6x, I'll subtract 6x. To move the negative 3, I'll add 3. 7x minus 6x is 1x. Minus 3 plus 3 is 0. 6x minus 6x is 0. 3 plus 3 is 6. And by doing those two steps at the same time, addition, subtraction only, I'm able to solve this significantly quicker. If I do the check, the key with the check is always go back to the original equation. 7/15 times 6 minus 1/5 is 2/5 times 6 plus 1/2. This is a place where using the calculator is very nice. Decimal 2.6 equals 2.6, you will get a true statement telling you that 6 is the solution. But going ahead and writing it out into the original, that's going to tell you if you made any mistakes when you distributed or when you cleared the parentheses and cleared the fractions. If you check it just in here, that only tells you that that equation was solved correctly. Doesn't tell you that the original one was solved correctly. So always go back and check in the original. If we have decimals, they're going to work in the exact same way. I want to clear my decimals, but I'm going to clear parentheses first. So 0.2 times 5 is 1. 0.2 times 6 is 1.2. And I have 0.8x plus 4.8. Now at this point, a decimal is nothing more than a fraction with a denominator of some power of 10. So what I'm going to want to do is I'm going to want to clear those decimals. I've only got one place behind the decimal in any one of my numbers, so I'm going to multiply both sides by 10. That's going to serve to move the decimal one place. 10 times 7 is 70. 10 times 1 plus 10x. 10 times 1.2 minus 12. 0.8 times 10, 8x. 4.8 times 10, 48. Now I've got a number with no decimals or fractions. To solve this equation, combine like terms. 70 minus 12 is 58. I've got variables on both sides. I'll subtract 8x from both sides, giving me 2x plus 58. 8x minus 8x is 0. Double check that because it's easy to make a careless error there with signs and then not see that you had 8x plus 8x, which would be 16x, for instance. So do always look. 8 minus 8 is 0, is 48. Variables on one side, I need my constants to the other. So to get rid of the plus 58, I subtract 58 on both sides. 58 minus 58 is 0. 48 minus 58 is negative 10. Get rid of the 2, it's stuck by multiplication, so undo by division. And we get the solution, x is negative 5. This is not hard to do even if you don't have a calculator. Working with the decimals, you may make many careless errors. So you can always clear the decimals, just like you cleared fractions in an equation, multiplying both sides by the common denominator. For the check, 7 plus 0.2, 5x, I'm claiming x is negative 5, minus 6 is 0.8 times x, I'm claiming x is negative 5, plus 4.8. Use the calculator, do the check. Calculator is great for doing the checks. 0.8 equals 0.8, true statement, so the number we plugged in is the solution. And finally, more decimals. Well, remember, a decimal is nothing more than a fraction with denominator of a power of 10. So 0.08x really means 8/100ths. Minus 0.31, 0.05x, minus 0.3. The most places I have behind a decimal is 2. So I'm going to multiply both sides by 100. So I've done the same thing on both sides. 100 times 0.08, that'll move the decimal 2 places, and I just have 8x. 100 times 31 out of 100 gives me minus 31. 0.05 times 100 gives me 5. And be careful, this is 3/10, which would be 30/100ths. So 0.3 times 100, my decimal moves 2 places, and I have minus 30. Okay. From here, it's going to be, should be pretty easy. Variables on both sides. So I will want to subtract 5x from both sides, and then I'm going to want to get rid of the negative 31. 31 was subtracted, so to undo, I will add 31 on both sides. 8x minus 5x, 3x. Minus 31 plus 31, 0. 5x minus 5x, 0. Negative 30 plus 31, I owe 30, I have 31, 1. To get x by itself, get rid of the 3. It's stuck with the x by multiplication. Undo multiplication by division. And we get x is 1/3. Now, on this example, if you had worked just with the decimals, at this point you're going to be getting x equals 0.33333333. That is not an acceptable answer here, again, unless you need to round if you're working with a word problem. We want to leave the answer, we want the answer to be exact. 1/3 is exact. 0.3, even with the bar over it, that doesn't give us something we can do much with, and checking that would be just about impossible. Again, hello calculator. Here 0.08 times x, I'm claiming x is 1/3, minus 0.31 is 0.05 times x, which I'm claiming is 1/3, minus 0.3. Just punch it into the calculator as is. If you're doing the fraction to decimal conversion, you're going to get negative 17/60 is negative 17/60. Play with these. Clear parentheses first, then clear your fractions or decimals, and then these problems become relatively easy to work.